Welcome to Channel 137. Imagine this, the universe begins not with a gentle nudge, but with an explosion so violent that it sets everything in motion: space, time, energy and matter. We call this the Big Bang, an event that's often described as the starting point for everything we know. But here's the mind-bender. The Big Bang was faster than light. Space itself expanded so quickly that in the first fraction of a second, distances between points in the universe stretched at unimaginable speeds, much, much faster than light could travel within that space. If nothing can go faster than light, how can space itself expand faster than light? Isn't that a direct contradiction to Einstein's theory? Einstein's most famous insight through his theory of relativity told us that nothing can exceed the speed of light. It's the ultimate cosmic speed limit. But here's where things get interesting. Einstein's rule doesn't apply to space itself. In fact, space can stretch as much as it likes, faster than light, and it doesn't break any laws. So Einstein might have set limits on how fast objects can move through space. But he never said space itself couldn't expand faster than light. It's like having a rug that you're standing on, and someone starts pulling the rug. You're not moving, but the rug space is expanding beneath you, making it seem like distances are being crossed faster than you could ever run. If the universe began faster than light, can we find ways to push past those limits now? Here's where it gets mind-bending. Let's talk about what stops us from continuing to accelerate faster and faster in space. The vacuum of space is vast, empty and frictionless. There's nothing to hold us back. So why can't we just strap rockets to a spaceship, fire up some boosters and keep accelerating faster and faster forever? There's nothing to stop us. In space, once you start moving, you keep moving. Newton's law of inertia tells us that. Why don't we just keep speeding up, faster than light, until we break that cosmic speed barrier? In theory, we could. If we had an endless supply of energy, think of an atom bomb exploding constantly. Its raw power pushing us through space over and over, faster and faster. Imagine it. Your spaceship begins at a modest speed of 22,000 kilometers per hour. You hit the booster, and now you're doing 100,000 kilometers per hour. Another burst, and now it's 500,000 kilometers per hour. There's nothing in space to stop you. Another explosion, and you're going 1 million kilometers per hour, then 10 million, faster and faster. What's stopping you? Nothing, right? Now we're talking pure acceleration. Theoretically, with continuous force, the speed limit shouldn't exist for us. We have the energy, we have the physics. We just keep firing off explosions, and eventually, boom, we're moving faster than light. Except here's where Einstein's shadow creeps back in. As we keep pushing that spaceship to go faster, something really strange starts happening. The faster you go, the heavier you get. Well, not heavier like you're gaining mass, but in a way that your energy is being converted into mass. This is where Einstein's famous equation E = mc squared comes into play. The more energy you pump into your ship to push it faster, the more of that energy becomes mass. You're not just speeding up anymore, you're becoming a denser, more massive object. It's like the universe is rigged. The faster you try to go, the more resistance you meet, not from friction or air, but from reality itself. You try to push harder, and you get heavier. And as you approach the speed of light, it's like you're running into an invisible wall. It would take infinite energy to actually reach the speed of light. So even with an endless supply of atomic explosions behind you, it's like the universe is conspiring to slow you down. But here's the crazy part. What if we didn't care about that? What if we found a way to keep accelerating? Because when you think about it, we're already doing this. Every atom bomb, every nuclear explosion, every burst of energy we've ever unleashed is just a tiny fragment of the universe's raw potential. There's no reason, fundamentally, why we can't keep pushing forward faster and faster. Maybe the issue isn't that we can't go faster than light. Maybe the issue is that we haven't figured out the right way to push ourselves through the cosmos yet. And what if we could unlock a form of propulsion that keeps accelerating without bound? Imagine tapping into dark energy, the mysterious force that's already pushing the universe to expand at an accelerated rate. Could we harness it? Could we use the same energy that drives the expansion of galaxies to push our own ship? Maybe the key is to use the universe's own natural accelerators, forces we've only begun to understand. Think of the Big Bang again. Space expanded faster than light. What if we could figure out a way to bend space the way the universe did in those first few moments? Forget about moving through space. What if we could make space move around us? Warp space in front of us, like folding a piece of paper and bringing two distant points closer together. Suddenly, the speed of light isn't a limit anymore because we're not moving through space, we're moving space around us. And here's another mind bender. If light is the fastest thing in the universe, why does it take light years to travel across the universe? If the speed of light is truly infinite in its power, then shouldn't it be able to cross the universe instantly? Why do we see light from stars that took billions of years to reach us? Maybe there's a deeper truth here. Maybe light isn't the limit we think it is. Maybe the speed of light is a consequence of a bigger set of rules. And those rules are only governing this universe, the one we happen to find ourselves in. What if we could break out of those rules? What if the speed of light is just a limit inside this realm, but beyond it there's something faster? In quantum mechanics, we already know about spooky action at a distance. Quantum entanglement, where particles seem to communicate instantly across vast distances faster than light. That's not just theory, it's been proven experimentally. Maybe this shows us there's something faster than light, but we just haven't wrapped our heads around it yet. Why think that Einstein's rule is the ultimate one? Every law of physics we've ever known has been challenged by something deeper, more fundamental. Newton's laws gave way to Einstein. Einstein's might give way to something else. There's no reason to believe that the speed of light is the final barrier. What if it's just the first barrier, the one we need to overcome to see beyond? If we keep accelerating, pushing, firing those boosters, maybe we'll reach a point where we can break the rules. Maybe there's a hidden key in the universe, something encoded deep within space-time that says, yes, you can go faster, you just haven't figured out how yet. The atom bomb is a tiny glimpse into the universe's power, but that's human-made. The universe itself has far more energy at its disposal. If the universe can expand faster than light, if it can break the rules during the Big Bang, what's to stop us from doing the same? Nothing is stopping us from continuing to accelerate. Maybe one day we'll look back and realize the speed of light was just one speed limit among many one step in a much larger journey. One day we'll push past it, and when we do, we'll finally see what's on the other side. Because in the end, every limit we've ever faced was meant to be broken. And who knows? Maybe light is just waiting for us to catch up. Thanks for joining us. Until next time, keep wondering. And if you enjoyed this journey, please like, subscribe, and stay with us as we continue exploring the unknown together.